Alrighty, guys, welcome back to week 18. Let's go. If this is your first time, solid week to show up. Tonight is the payoff session where everything clicks together. Before we get into it, week has been dope. Just shaking up my creatine and in the gym. Noticed I've lost even more off my waist. So that's been really awesome. Just really cutting down, getting into shape. Um, Feeling a lot healthier. So yeah, still applying to jobs. Unfortunately, I had one application that went through the whole thing, and it's just they're using a terrible site and it glitched out and they won't even submit. So tried numerous times. So fun stuff, fun stuff. But just going to keep applying. But other than that, last week was TypeScript fundamentals, types, interfaces, unions, generics. Type interface, the whole mental model. We treated JavaScript like it grew up and got a job. Tonight we apply it directly to React, the components, hooks, and patterns you've been building since session 12. So we're going to type all of them. I promise you, once you see these typed props and typed hooks, going back to untyped React feels like driving without a seatbelt. Again, there's going to be no live code tonight, just slides and code examples the whole way through. Without further ado, let's get into it. So why React at all? Before we write any typed React, TypeScript React, let's answer the obvious question. Why bother? React works fine without TypeScript. Why add it? Um, it's fair. I'll give you 3 reasons why, and why they actually matter in the real world. First one, autocomplete. That actually knows your data. When your type player in a typed component, your editor shows you every field on that player object. No guessing, no checking the console. It's right there. This alone saves hours over the course of a project. Reason 2, errors at write time, not runtime. Without TypeScript, you find out you passed the wrong prop type when the app crashes in the browser. Nobody likes that. With TypeScript, you find out the moment you type it. A red underline, clear message, fix it immediately. That's it. The feedback loop goes from minutes to seconds. And then number 3, of course, props are self-documenting. In plain React, when you use a component someone else wrote, you have to read their code or their docs to know what props it takes. With TypeScript, you hover over the component and your editor tells you everything. Which props are required, which are optional, what type each one is. The types are documentation. This is why every serious React code base uses TypeScript. It's not about being fancy, it's about moving faster with fewer mistakes and showing interviewers that you know how to do this, and to even potentially even speed up their pre-existing work would be amazing and super valuable. Now we have our typed props. Props where TypeScript makes the biggest immediate difference. In plain React, there's nothing stopping you from passing the wrong type to a component. And TypeScript's going to fix that for you before and after. Um, Here's the pattern interface for a prop. That with it's semicolon. Player card props. After the destructured props is all it takes. Now TypeScript knows exactly what this component expects. Try to use it wrong, it gets caught immediately before it ever returns. Show you guys. So boom, 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 boom. Optional props. Not every prop is required. Use a question mark to make something optional. We also went over those in the last 2 sessions. Inside the component, TypeScript knows streak might be undefined, so it'll warn you if you use it without checking. The streak and guard isn't just good practice. TypeScript will actually flag you if you try to use streak directly without handling the undefined case. So, ooh, there we go. So default values with optional props, like our function player card, right here. So what's the difference between a required and optional prop in TypeScript? No question mark equals is required. TypeScript errors if you forget it. Question mark equals optional. TypeScript knows it might be undefined and makes you handle it. So the question mark. Boom, 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 boom. Typed useState. So useState is where beginner TypeScript React code gets sloppy. But the fix is easy once you know it. TypeScript infers simple state automatically. So when the initial value makes the type obvious, TypeScript figures it out. You don't need to annotate every useState. This is the pattern for async data. Starts null, becomes a real type after the fetch. Some common mistakes. The never with the arrays brackets gotcha catches everyone for the first time. If you initialize state with an empty array, always add the generic type. Event handlers in React have specific types that TypeScript does expect. This is one of the most Googled things in TypeScript React. Let's just nail it tonight. So on click, so your on clicks and on changes are your most common ones, along with on submit, of course, and these are the patterns that you want to try to remember on how to write them, because they are different from React. Okay, yes, it is React, but the way we write in TypeScript is a little different. So every type plus the HTML element type, um, the event type plus HTML element type. Once you've seen it a few times, it then becomes muscle memory. So you know it's React, always starting with React, capital, and then capitalizing again and going with its event, and then its HTML type. Pretty simple. And this is what they look like in action. React, event, HTML type. React, event, HTML type. It's like it might be important for the game or something. So this is where everything from session 11 and 12 comes back together. Async data fetching, useEffect, and now TypeScript types on top. You want to define your data shape first, then typed fetch function, like promise, tells TypeScript what this async function resolves to. When you await it, TypeScript knows the result is player. And then, of course, the typed useEffect with fetch. Notice the error instance of error. TypeScript catches a typed as unknown by default. Checking instance of error is the right way to narrate before accessing the message. This is the complete async data pattern. Every field is typed, every state variable is typed, every error is handled correctly. So just make sure you're, you know, reading through these and looking at how they get written. That's the way to do it. So useref has two use cases, and TypeScript handles both slightly differently. DOM-refs, userefs, pointing at an element. The generic HTML input tag tells TypeScript what methods and properties are available on ref.current. If you try to call a method that doesn't exist on that element type, TypeScript will catch that. Some common element types, like these. Mutable refs, storing values without re-renders. The key difference here is DOM refs initialize with null because the element doesn't exist yet. Mutable value refs initialize with the actual starting value. So, kaboom, boom to generic components. This is the advanced move here. Building reusable components that work with any data shape. This is what separates a component library from a pile of one-off components. Now the problem here, boom, and then the solution. You can use it with the players, use it with anything else. The list with messages, with players. One component, any data. TypeScript enforces that render item receives the same type as the items in their array. This is how component libraries like React Table, React Select, and Headless UI are built. Generic components are the reason those libraries work with any data you throw at them. And finally, move to the real world build. Everything typed into one fully component. We're going to put together in one fully typed component a leaderboard card, the same thing we've been building all season, but now it's fully typed. Like, um, let's see. Like, look at what's typed here. Player interface. Every field has a type. Streak is optional. Leaderboard props. Both props optional with defaults. useState. Boom. useState on players. Can't accidentally put in the wrong data. useState on all. Yep, useState on all. There we go. This one filter can only be one of two strings, nothing else. Handle filter change. Let's see. The event type is explicit, and then our event target value as all or active. Oof, sorry. Boom. Assertion to tell TypeScript we know what the values will be. This is production TypeScript React. Every piece has a purpose, and that's it. Every typed piece, boom, 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 accounted for. Shape, props, player state, loading state, filter state, bend handler, streak props. Whether it's optional with a question or not. So game time. Fucking game time. Let's go, y'all. Flying through today just because it doesn't look like we had anyone show up today, which is totally fine. We're still going to run these things anyway, y'all. It doesn't bother me one bit. Everyone has lives. Everyone gets busy. And this will be the best time to tell everybody. So next week, I will be going out of town after next week. So I will be double filming on next Tuesday. And I'm going to try to set it up to have the video drop on YouTube while I'm gone. If I can't figure it out, I might have to drop it as soon as I get back, which might be a Wednesday. But that following week, we will not have a live session because we're doubling up on a week. But we will still be making sure we get out the same exact amount of videos that we should have per week. And we're going to keep this bad boy fucking running. There's nothing fucking stopping me, and there's nothing stopping you guys. So we're going to do this shit together. Without further ado, what does the question do in TypeScript interface props? Well, we know. As soon as we see optional, we already know. What is wrong with the useState call? Let's see. Boom. An array that can never hold items, so set players will always error. What is the correct type for an onChange handler on an input element? Ooh, a change event or input event. I would say input. Oh, change event. It'd still be a change event. Oh, because it would be on an input element. That's right. So change event, input element. Yep. How do you type a useState that starts as null but will eventually hold a player object? Doo-doo-doo-doo-doo. 1, 2, 3 are all the same. Really don't see the difference here. It looks like some of the code might be missing from that. What does this typed fetch function signature mean? How do you type a useRef pointing to an input element? Well, it looks like we're missing some stuff again, boys. What does this union state mean? The filter is not optional. There's no question mark. Filter is typed as a Boolean with 2 string labels. That's more identifiable. We didn't even read the last one. Will never be a string. Yep, that gave it away right there. All or the string active. Yeah, we should have read them all. When do inline event handlers not need an explicit type annotation? Um, What is the purpose of the T in the generic component? T is the placeholder. Knew that right out the gate. Why do you need instance of error when catching it in TypeScript? Instance of error. Instance of error. Instance of error. What is the difference between a DOM ref and a mutable ref in TypeScript, y'all? Oh, DOMs. Oh, this first one. What does this prop interface communicate to other developers? Both props are optional with no defaults. The component must handle undefined internally. What does TypeScript give you for free that plain React doesn't? Faster component rendering at runtime. Errors when you pass blah blah blah. Yep, of course, the long one. What is the correct fix for this type use state? Um, missing. Not bad, not terrible, not great. Alrighty, I'm gonna save this for all of everyone who was unable to make it. But thank you guys. Thank you guys again for showing up. This was just another amazing week. That's session 18 though, TypeScript plus React, type props. Let's see. Pull that up. Yep. Type props with interfaces required and optional. Typed use states, generics, nullable state. The never gotcha. Typed event handlers, MouseEvent, ChangeEvent, FormEvent, typed API calls and useEffect. Promise types, unknown errors. Typed use refs, DOM refs versus mutable refs. Generic components, reusable across any data shape, and a fully typed leaderboard built from scratch. Now now your React is now typed. That's a different tier. Next week, we keep building, testing, or real world project patterns. We're going to figure it all out together. I'm going to make sure that those next 2 sessions really go together, especially since I'm going to have that 1 week where I'm gone and we're not doing a live sesh. So if you're not in Discord yet, please drop a comment, shoot me an email, send me anything here at all, and I'll make sure I get you guys in the Discord. This is the channel. People are always in here. We have different resources. Like I said, I drop all of the decks, the mermaid sheets, the games. I always announce what we're doing for the next and upcoming weeks, off topics, ideas for the next meetings, UI, any other branches that we have in here. So please feel free to jump in. I always like to reach out to everyone, message, and help you guys build and work. So let's get her done. I will see y'all on the next one.